Okay, so last video from this section on the chain rule. And the last thing we're going to do is just apply the chain rule whenever the log, we're going to fix the outer function to be the log function, or in particular, the natural log function. Remember, the derivative of the natural log is just 1 over x. We're not dealing with any other kind of logs with different bases. It's just the log with base e. So this is just log base e. All right. Okay. And so you've seen the chain rule a bunch of times by now. If you haven't, this is what it is. It just tells you how to take the derivative of a composition of functions, and you have to do it in a particular way, not probably the way you would initially guess it. Okay? But basically it goes, you take the derivative of the outer function, you plug the inner function into that, then you take the derivative of the inner function and you multiply it to what you got before. You multiply it to what you just computed. So let's go ahead and do some examples. All right, so here we go, ln of 4 times x to the 5th power. So we did an example like this in a previous video, but we were using, log rules to sort of split it up and do all of this stuff. Well, let's forget about that for now. Let's just say you know the chain rule, you forgot all your log rules, and now you want to take the derivative of something that looks like this. It's log of 4 times x to the 5th power. How are you going to do it? You know that the outer function is a log, so how does it go? You take the derivative of the outer function, that's just 1 over whatever's inside, because that's what the derivative of log, that's what log does when you take the derivative of it. It's just 1 over what's inside, but now you have to chain what's inside. So you multiply that by the derivative of what you plugged in. So that's just going to be 20 times x to the 4th power, just the power rule. And so when you simplify this, check this out, you get 1 over 4 x to the 5th, but then you, on the top you have, so times 20 x to the 4th, and of course you could put divided by 1 if you want. I don't know if that helps you or not. But what do? You divide 20 by 4, you get 5. You divide x to the 4th by x to the 5th. So if you have 4x's on the top and 5x's on the bottom, how many are you left with and where? You're left with 1x on the bottom. And there it is. The answer is 5 over x. And that's exactly what we got in that previous video, where you basically just bring the exponent down, because that's one of the rules of log, and you ignore the 4 because whenever you take the derivative of it, you're always going to cancel it out later. Okay, so the chain rule works just as well, and you could avoid using the log rules. Okay, so let's move on to the next example. This time we're going to plug something slightly more complicated in the log. In particular, we're going to plug in an exponential function inside the log. So how is this going to go? The derivative of log is 1 over what's inside. And now you got to be a little careful. How are you going to take the derivative of what's inside? Because now you have to do the chain. Well, 3x is a power function, so the derivative of that is just 3. But 3 to the x is an exponential function, so the derivative of that is itself times ln of the base. And that's it. If you simplify your answer, you get 3 plus 3 to the x times ln 3. And you divide by 3x plus 3 to the x. That's the final answer. Done. Okay, another example. Let's say you plug a log inside a log. All right, so how's this going to go? You're going to have to do 1 over x times 1 over x, something like this, you should be thinking. Well, let's see how it goes. Right, so what's the derivative of log? So here's my first log. It's the outer function, so it's just going to go 1 over what's inside. Aha, okay. But now what was inside was x plus ln x, so I have to multiply by the chain. So I have to chain that, and you get times 1 plus, well, what's the derivative of ln x? That's 1 over x. You see? So the final answer is 1 plus 1 over x divided by x plus ln x, and it's fine to leave it like that. Although it's not customary or nice to leave your answer with a fraction over a fraction. So if you want, you could simplify it, and I'll do that for you just so you could see how that would go. So on the top, you would simplify that, or you'd clean that up by combining that fraction and making one big fraction out of it. So 1 plus 1 over x is the same thing as x over x plus 1 over x. That's the same thing as 1 plus x divided by x. But you're taking that and dividing by x plus ln x. Okay? And so what's a fraction divided by something? Well, it's the same thing as taking what's on the top and multiplying by 1 over what's on the bottom. Okay? And so I'll write the final answer up here. It's going to be 1 plus x divided by x times x plus ln x. And there you have it. A nice, clean, single fraction. All right? And so actually, just not to be confused, this is fine right here. All right? All this other stuff, that's just extra work to make the answer look sort of nice. Okay, but so let me just bring it home here. This is acceptable, and this is nice. Okay, so one last thing. Last time, or in the last video when we had the exponential function as the outer function, we actually derived the formula for the derivative of of ln x. So actually, this should be e to the x. So this time we want to find out why should the derivative of e to the x be itself. All right. In the previous video we did why the derivative of log was 1 over x. So let's assume, so we know that the derivative of natural log of x is equal to 1 over x. And this is what we want. We want to show this. Because last time I just gave it to you and you didn't know why it should be like that. So let's check it out. The special thing we're going to need to use here, in addition to the formula for the derivative of log, is the fact that natural log and e to the x are inverses of each other. In other words, when you take e to the x and you plug it into log, you're just going to get x back. Okay, well, remember how this thing goes? And let me write it a little bit better. So we also know that ln of e to the x is equal to x. So when we take the derivative of both sides, what does the chain rule say? It says the derivative of log of something is going to be 1 over that something times the derivative of that something. That's what the chain rule says. Derivative of the outer function times the derivative of the outer function with the inner function plugged in times the derivative of the inner function. So this is going to be equal to, well, the derivative of x is just 1. And guess what? Solving for d dx of e to the x, you get that it should be equal to, multiplying both sides by e to the x, just e to the x. All right, and so let me write that out here. So d dx, e to the x must be equal to e to the x, and there you have it. That is how you can derive the formula of the derivative of e to the x, knowing just the derivative of log and the chain rule. And that is it for chain rule. Hope you get lots of practice with the problems and the web work problems, with the recommended problems and the web work problems as well.